Alright, this is the last section, section 8.5. This one is not in the textbooks, but this is something that's important. Natural logs. You're going to see this lots. This is remember when I said that base 10 is one of the most common bases? This is one of the other ones. So this is very important. I don't know why it's not in the textbook. I think it should be. So this is something that I wanted to show you so that you can see it and that you understand this. Let's try this out. So, what is the purposes? Notice I'm starting to get fancier with my transitions. I figured sometimes it's fun. Sometimes it's too much, but just for the sake of this one, I thought I'd go crazy. So we're going to discover what are the properties of natural logs, and we are going to solve problems involving this. This has been a common theme throughout this entire unit. Yep. So, what are some properties? A natural log is just a log with a very specific base. So log base e of x equals ln x. This is an lowercase l. It is not an I. I don't know how many people say log base e of x is equal to in x. It's not in, it's ln. Pronounced lawn, like your yard is a lawn. That's what it is. That is your case. Now, e is a constant value. It equals 2.718 something. You don't really need to know that. That's not the important part. You just need to know that ln x is equal to a very specific base of log. That's all you're doing. That means that all of my rules for logs also apply to natural logs. It's the same thing. It's just a very specific base. So if we look at logs, you've got three rules. I've got the product rule, I've got the quotient rule, and I've got the power rule. These are going to be the exact same thing for logs, except instead of log base c, you replace it with ln. So ln of xy equals ln x plus ln y. If I've got a fraction in a ln, it's just ln x minus ln y. And if I've got a power, I can bring that power up front. So this whole section is not anything crazy. It's just taking what you know and looking at a very specific case. The reason why e to the power of something is something special, it's referred to as like a natural growth rate or a natural growth rate. So if remember we talked about like a question with bacteria, it doubles every day or triples every day. So in actuality, they've tested this out, and most grow at a rate of e. That's just kind of technically where it comes from. Again, you don't need to know all the specifics of that. It's a number that's used often enough, and you will see ln very commonly. So let's try some. Simplify. We're going to apply the same rules. I've got a ln minus a ln. So to put them together, I put in a fraction. Simplify that fraction. There's the answer. Again, all I changed is logs to lns, but the process is the exact same. Look at a different one here. Ln of 9x to the 4 plus ln 3x squared. Again, they're a ln plus a ln. I just multiply what's inside the brackets, put them together. There's my answer. So just showing this is really straightforward. There isn't anything overly complicated, just different numbers in front. So let's look at an example such as this. I want to solve for x. So first of all, I need to simplify the left-hand side to make it under 1 ln. Then I can cancel out those lns. So first I'm going to put that 2 at the very beginning to a power. Then I can combine all these. So the positive lns go in the numerator, the 10 goes in the denominator. Simplify all that out. In order to cancel out a ln, I do e to the power of that. So just like 10 to the power of log cancels out, or log base 2, 2 to the power of log base 2 cancel out, e to the power of ln cancels out, and I get x equals 8. Really, really not too bad. How about something like this? So this one looks a little bit more complicated, but let's break this down into steps. So I want to simplify ln of e to the 3 times ln e to the 5. That looks a little bit like a mouthful, but let's try this. First things first, inside my bracket I have e to the 3 times ln e to the 5. So I can separate those into two separate lns. Okay, nothing too complicated there. Then using the power rule, I'm going to take the power of 3 and move it in front of the ln. I can take the power of 5 and move it in front of the ln that's right beside it. So I get something like this. Just like e to the power of ln cancels out, ln of e is just 1. That's essentially saying e to the power of what equals e. So it's just 1. So that simplifies my expression into, I just stated that, equals this. And that's the simplified form. So that's all you're doing for this. Work it step by step, figure it out, using the different rules, the 3 rules that we know of. That is that. That's all done for chapter 8. That's lawns. There we go. Not too bad. So welcome to the end of chapter 8. And that's it. Turns out my base is being watched. Should have suspected that. Well, this is it. It's up to you now. There's nothing more I can do. Without you, without your liking my videos, without you subscribing, the world is going to end as you know it. And many lives are lost. Many more will come. And just pure evil is going to reign. So it's up to you. Only you have the decision to change the world. Now go out and do that.